Hello, Professor. Welcome to my performance task number 2. This is Intro to Chemistry Fall of 2025, and I am Molly Cogdill. So, question number 1 asked us to classify these substances in the table as ionic or molecular. The first one was calcium acetate. This is an ionic compound. It's not covalent, so it doesn't share electrons, they transfer. It contains a charged calcium ion and a negatively charged acetate ion, which means that it's an ionic compound. The oppositely charged ions from the ionic bond hold the compound together. It's a metal and a non-metal. Then we have iron 2 fluoride, also known as ferrous fluoride. This is also an ionic compound. It's not covalent, it doesn't share electrons, they transfer. It is a metal, the iron, and a nonmetal, which is a polyatomic ion, fluorine, fluoride, which makes it an ionic compound, a metal and a nonmetal. It contains, again, a charged ion, iron ion, and negatively charged fluorine ion. The oppositely charged ions create an electrostatic force that holds the ionic compound together. Again, the third ionic compound is iron 3 sulfate, also known as ferric sulfate. This is not covalent, also doesn't share electrons. It is a metal and a nonmetal. It contains a positively charged iron ion and a negatively charged sulfate ion. So again, the oppositely charged ions hold the compound together. The fourth was nitrous oxide, which is a molecular compound, unlike the other ionic compounds. So this bond is covalent, so it shares electrons. Two nonmetals, nitrogen and oxygen, make it molecular, and it results in a distinct molecule rather than the ionic lattice structure that are formed from these. And then it asked us what the formulas are and how we found the formulas. Calcium acetate and iron fluoride. So for calcium acetate, it is Ca, calcium, and then in parentheses, C2H3O2, and then in parentheses 2. So calcium is Ca, and that has a positive 2 charge. This is in group 2 on the periodic table. And then acetate, this is the formula for acetate, C2H3O2. This has a negative 1 charge. This isn't on the periodic table, it's a polyatomic ion, so it's on the ion table. So you write out Ca, which has a positive 2 charge, and then you write out the C2H2O2 for the acetate, and this has a negative 1 charge. So you want both of these together to have a 0 net charge. So the positive 2 and the negative 1, we need to times negative 1 by 2 to get negative 2 to cancel out the positive 2 in the calcium. So if you take out my crisscrosses, you end up with Ca parentheses C2H3O2 2. And then for iron 2 fluoride, the formula is FeF2. So the symbol for iron is Fe, and fluorine is F. These are on the periodic table. Iron has a positive 2 charge, and fluorine has a negative 1 charge. It's in group 17. So Fe, again, positive 2 charge. F is a negative 1 charge. So we're going to want 2 of the negative 1s to equal 2. In these ionic compounds, the net charge must be 0, so they have to balance out each other. So if you take away my crisscrosses, you end up with Fe, F2. And then it asks us to take each formula and then kind of break down how we got the name of each substance. So Fe2SO4 in parentheses subscript 3. So the Fe is iron, which is a transition metal. It has a charge of +3, which is where the 3 comes from. And then the SO is sulfate, charge of -2, which is a polyatomic ion. So a metal and a polyatomic ion, so it forms the ionic bond. So you take the charge of +3, and we're going to times that by 2. 2 is here. And then we're going to take the charge of -2, and we're going to times that by 3. So they're each going to equal 6 and -6 with a net charge of 0. So that's how we got 2SO3. I don't think I wrote iron 3 sulfate altogether. So sorry. Iron 3 sulfate. Iron 3 sulfate. And then N subscript 2O. Nitrogen is the N. O is oxygen. So this is nitrous oxide, which we know. I use this a lot in dental, actually, because we give this laughing gas to patients who are getting certain extractions done. But it is also known as dinitrogen monoxide. So the D, di, equals 2 nitrogen. And then the mono equals 1 oxygen. There's no subscript, but we know there's only 1. And then the ide lets us know it's a binary compound, aka laughing gas. So a lot of people know that nitrous oxide is also known as laughing gas, and that's due to the funny euphoric feeling when you get when it's inhaled. And then question 4 is calculate the molar mass of CrSO4-2. So step 1, how many atoms are in each element? So the chromium, Cr, has 1 atom. The sulfur, the S, has 1 atom in the sulfur right here, but it's in the parentheses of 2. So you're going to do 1 subscript of 2 equals 2 sulfur. Oxygen, inside the parentheses, has 4, but then a subscript of 2. So 4 times 2 equals 8 oxygen atoms. Step 2, what is the molar mass of each element? And you use the periodic table to find this. Chromium is 51.996 grams per mole. Sulfur is 32.07 grams per mole. And oxygen is 15.999 grams per mole. Step 3, what is the molar mass of the entire compound? So the molar mass is going to equal 1 times the molar mass of chromium, 2 times the molar mass of sulfur, and 8 times the molar mass of oxygen. So 1 times 51.996, 2 times 3207, and 8 times 15.999 equals 51.996 plus 64.14 plus 127.992, which makes the molar mass of the entire compound 244.128 grams per mole. Okay, and then number 5, calculate the mass of calcium acetate in 0.65 mole. So this one's kind of hard to me. So first, the formula is Ca in parentheses C2H2O2 parentheses 2. We used this earlier in, I think, question number 1 or 2. So the sum of the atomic masses of the atoms. So calcium, there's 1 calcium atom, so times 40.08. Carbon, 4 times 12.01. Hydrogen is 6.1.008. And oxygen is 4 times 16 grams per mole. So the molar mass is 40.08 plus 4 times, So the molar mass is 158.17 grams per mole. And then the mass equals moles times molar mass. So the mass equals Now this is where it comes back to this. So it's only 0.65 mole. So mass equals 0.65 mole times 158.17, the molar mass, and that is going to equal 102.81 grams. And then you're going to round that to two significant figures because there were two significant figures in a given value of 0.65 mole. So the mass is 1 times 10 subscript 2 grams. And then, how many liters of nitrous oxide gas are at STP in 15.7 grams of nitrous oxide present? Step 1, find the molar mass of the nitrous oxide. So we are going to do 2 times 14.01 plus 16 equals 44.02. That's the molar mass of nitrous oxide. And then we're going to convert the mass to moles. So moles equals mass over molar mass. So the moles equals 15.7 grams over the molar mass we calculated, 44.02 grams per mole, which is going to equal about 0.3567 mole. So the grams here are going to cancel each other out. Step 3, convert the moles to the volume at STP. At STP, about 1 mole occupies a volume of 22.4 liters. So the volume equals moles times molar volume at STP. So the volume is going to equal 0.3567 mole, which is what we got up here when we converted the mass to moles, times this standard volume, which is 22.4 liters per mole, which is going to leave you with a volume of about 7.99 liters. And then lastly, which of these two contains more iron ions? So first is 5.8 times 1021 particles of Fe2SO43. So there's two ions of iron 3+, and then there's one particle of the entire compound, which is going to equal 1.036 times 1022 ions, because we convert it back to the significant figures. So that is the answer for this one. And then 180.5 grams of iron 2 fluoride. And the formula is going to be FeF2, which we also used already. So first we're going to calculate the molar mass of iron fluoride. So 55.845 plus 2 times 18.998, because there's two fluorines, is going to equal 93.84 grams per mole. And then we need to know the number of moles in the compound of the iron and the fluorine. So it is 180.5 grams of the compound over 93.841 grams per mole, which is going to give you about 1.924 mole. And then the number of iron ions. So we have to use Avogadro's number for this one, which is here. So we are going to take the number of moles, which we just calculated here, and times it by Avogadro's number over 1 mole. And that is going to give our answer of the number of iron ions, which is 1.159 times 1024 ions. So you can see here that this contains significantly more iron. Yeah. Anyways, thanks for watching.